So today we're going to be going over the light passes and AOV widget for Unreal Engine, currently available on the Fab Marketplace. If you want to render separate light passes out of Unreal Engine or have an easy to use render tool, then be sure to check it out. Link will be in the description below. So we have our scene here, skeleton in a cave lit with volumetric lighting. So we're going to use the tool to render this out. So the first thing you want to do is go to Edit, Plugins, and type in Movie. You want to activate the Movie Render Queue and the Movie Render Queue Additional Render Passes. Then you want to go to End Display. You want to activate the End Display plugin. You'll need all three of these plugins on in order to work. Once you activate them, you'll see this thing here at the bottom. I just unclicked it so you'll see. Called to say Restart Now. So you want to hit that once all of these are checked on. So once your engine is restarted, we'll go and find in the content browser the Render Pass widget folder, and you'll see a bunch of folders in here. The one we need right now is the Render Passes tool, and you're going to click on the BP_lightpasses_AOV widget. So right click, and you want to hit Run Editor Utility. I have mine docked up here. So we'll see a bunch of options here. And the first option is Render Presets. So what Render Presets are is a way to fill in all of these options with preset values so you don't have to go in and adjust it every time for every shot. So I have one made here already. It's demo sequence SS000_0010. And as you can see, it filled in all of my options for me. If you want to create your own, you can go back into the Render Passes widget folder and look for the folder titled Presets. Here you can see I have the demo sec presets. You can duplicate this and name it whatever you want. Double click this and you'll see this window pop up. And here you can adjust all of the options, save it out, and this will be your preset. So let's say I want to change it to a path tracer. I can do that and drag this in, and you can see all of the options have changed. So I'm going to bring back my initial render presets. The next one is target sequence. This is the sequence that you want to render. Going down to these options here, we'll start with render options. In the render mode, you have raster, path tracer, and end display. These are just as they sound, same as it would be in the movie render queue. Raster is for the native Unreal Engine render. Path tracer is for ray tracing renders. So you need to have in your project settings ray tracing turned on in order for this to work. Use hard ray tracing when available and support hardware ray tracing and path tracing. End display is for any end display renders. Underneath that, you have the resolution presets. So I've included a bunch of presets here for specific aspect ratios, as well as just some general resolution presets. As you can see, you can change them and they will change your movie resolution below. The only thing is that if you want to adjust this, you can see you won't be able to. You'll have to go back to custom and then you can adjust them all you want. So we'll just set this back up to our 2K scope. Version number is the render version you are on. So if we go to our file explorer and we go to our sequence where our output path would be, you can see I have the sequence name here and a version 2 because I had this set to 2. And if I was going to render a new one, version 3 would create a new version file, while version 2 would just overwrite the original files. For EXR, this checked on is true. This will set up your render as an EXR file, whereas if it's false, then it will render as a PNG file. The rest of these are all things that you would see in the movie render queue, like accumulator includes alpha, disable multi-sample effects, your compression for your EXR files, overscan percentage, use camera cut for warm-up, render warm-up frames, render warm-up count, stencil actor layers, and we also have an option here for console variables. And this will basically render out any console variables that you put in, just as it would if you added this in manually to the console command. I have some general ones here by default. You can delete or add as many as you want. Big thing to notice here is the output path. So in Unreal Engine, in order for this to render, you need a output path that has a corresponding drive letter. So for instance, this one right here, if you look at my file explorer here, this file path would not work. Going towards another computer will not work. You need to have a specific drive letter like this E volume here. Next thing we'll do is go down to color settings. This allows you to set up an OCIO config. You can see here I have a render configuration, setting my render to ACCG. And I've also disabled the tone curve. This is just the LUT that Unreal Engine has in its viewport. Going down into the sample section, you can see we have all of the options that you would have in the movie render queue: temporal and spatial sample count, reference motion blur for path tracing renders, anti-aliasing method and override anti-aliasing, game mode override, cinematic quality settings, texture streaming, LOD 0, disable HLODs, and use high quality shadows. Next big section is the AOV section. I have this split up into AOVs and tech AOVs. Starting with the AOVs, you'll see we have primary. So if I go into my nuke here, you'll see that primary is just the beauty render pass, everything included. The next one is light groups. So this is a big thing of this tool, is it allows you to render light groups or lights as separate groups to adjust and edit in compositing. So the way that this tool does this is it uses actor tags to separate the lights. We'll just go over to the outliner here and we'll open the lights folder, and there we can see all the lights that are in the scene. And we'll just start with our top light here, and we wanted this to be rendered separately away from everything else. We'll just say we'll hide all these so you can see what our top light is affecting. And we want this light to just be rendered on its own. So we're going to go into actor tags and we're going to type in top light. So we know what it is in Nuke or After Effects or Fusion or whatever compositor you're using. We know what light, what render this light is. So the next, we'll enable back all these. The next ones I want to focus on are these two, the main sun. So I want these two to render together. So I'm going to click on both and go to my tags, and I want to add in a cave hot spot main sun. Now you don't have to make it such a wordy actor tag. If this is your key light, you could simply type in key. I just name mine in specific ways so that when I'm doing compositing, I know specifically what that light is for, because sometimes I'll have like a sun secondary that adds just additional sunlight here, and I want to know that these two are separate from each other. So I'm going to go ahead and turn all these back on, and I'll just go ahead and add all of the light tags onto these lights. Okay, so now that all of our lights have the corresponding actor tags, we will know that they will render out properly. As you can see here in our file folder, under lights, we have all of our light passes here. So our cave hotspot background, cave hotspot foreground, cave hotspot main, cave hotspot mid, environment, rim, sun secondary, and top light. So just switching over to Nuke here, you can see that all of our lights were in fact rendered. And I've set up a breakout of just adding them in to each line until we get our final reconstructed image. The big thing in this tool is you want to make sure you're giving actor tags to all your lights so that they will hide those lights when needed. So even if you're not going to use the lights, you still want to just add an actor tag to them. It could be just a null actor tag, an NULL, but you want to make sure that every light has an actor tag. Now, if you want to exclude those actor tags, so say I don't want to render the sun secondary light, I can just go into the exclude light group and I will add in the actor tag for that light group. And now the sunset will not render a separate pass at all. You won't get a sun secondary pass, but you will get a pass for every other light group that has an actor tag. This next one, override light groups. This is for if you just want to render one or two light groups. Maybe you have all the light groups rendered, but you wanted to go back and change one or two. So let's say I changed my top light and my rim light, and I want to just render those two lights and no other lights. I can go into this override light groups and add two options. And I can take my top light actor tag and add that in, and I can take my rim actor tag and add that in. Now only these two light groups will render. The next option is for emissive. So in order to show this in the scene, I've added in an emissive here, just in the back corner here. I don't have the material on it yet, so we're going to do that right now. So go back to the camera, and I have an emissive path set in the demo sequence of the render passes widget. So if we go back to our render passes widget folder and we go to demo material, you'll see this emissive pass right here. So we're just going to go ahead and add that to our material, and you can see we have an emissive. So to show you what's going on under the hood here that the tool needs, you'll see we have just a basic emissive setup, output going into emissive color. And normally it could just be like this, and you'd get the same result, just a vector parameter. And I added a multiply with a multiplication of 2 to increase the brightness, and that goes in your emissive color. Now for this tool, in order for it to turn off and on the emissive, we need to add something in. That's where this second multiply comes in. So whatever you have going on over here, and it can be a huge node graph, no problem. At the end of it, right before it goes into the emissive color input of the material, you want to add a multiply and stick that right into your emissive material. And on the A side will be whatever it is you're going on. And the B side, you're going to have the scalar parameter called emissive pass mult, spelled exactly how it is, caps lock exactly how it is. The namespace is very important. So you can set this to a value of 1 as a default, so we still get our emissive. But as you see, if I go to 0, there's no more emissive. This is what we need for our emissive pass. So I'll just save this. Now that we have the emissive material on it in a way that the tool can read, we also need to assign a tag to it so that the tool knows that this is an emissive actor that we want to control. So we're going to make sure we have our sphere selected, and under the actor tab, go down to tags, and we want to type in emissive with capital E, so capital E, M-I-S-S-I-V, and this tag will allow the tool to know that this is an emissive actor. That's all you have to do for emissives. If you want to, in your projects, you can always just duplicate this or go in and grab the multiply and pass mult right here, copy it, and just paste it into any of the material setups you already have. The next option here is fog split. This will just split out any fogs or volumetrics you have. So if you have an exponential height field fog in the scene, it will separate it, hide it from every other pass, and render it as its own separate pass. Additional light passes AOVs allows you to create custom AOVs for each light group. So if you want to create a custom PPM that each light group will render out, you can do that here. I have just an example one here that just shows a red material. This will render out as a post-process material for each light group. The other custom AOVs we have here are for diffuse, spec, roughness, metallic, opacity, and subsurface. So these will not render out the light values of each of these or light components of each of these, but they will render out the materials of each of these for each light, which still can come in handy. Back up at the top of the advanced, you'll see render BP lights and BP light select. What this does is it allows you to render your environment blueprint light. So if you have something like a ultra dynamic sky or a good sky blueprint plugin that creates skies and lighting for you, This will allow you to render the distance light and the sky light as separate light groups for you to control in compositing. So you would basically check on true for the render BP lights and then select your good skylight or your ultra dynamic skylight in here, and the tool will do the rest for you. Under AOVs, we have tech AOVs. So to disable all tech AOVs and not render at a tech AOV pass, you can just click true here and none of these will render. But for this, we want to render them. I've checked off rendering the tech AOVs as 32-bit post-processing materials, and I've created an override anti-aliasing for the tech AOVs and set it to none. I've also included a world normal, world position, world depth, AO, and motion vector pass. These are the passes that you would also see in the movie render queue. And I've created a separate option here as well for custom tech AOVs. So I'm rendering a custom depth AOV to help me in compositing with creating a depth of field effect. But if you wanted to have your own post-processed materials for a UV PPM or any other post-processed materials that you have that you want to include in your render, this is where you'd add them. Just make sure custom tech AOVs is checked on as true. And then you can add as many to the array as you like. Just make sure that they're enabled here as well. Just going into our nuke here so we can see our tech AOVs by just adding in a shuffle here. Putting it at the bottom of our tech AOVs. And we can see that our custom depth was rendered. Our world position, world normal, world depth, and motion vectors. And now we can use all of these passes in our compositing. These IDs, and these are your crypto IDs. So we'll go into our nuke here, and I'm just going to add, you can see we have our 3 crypto IDs. I've rendered them as material, actor, and full. And we can just add in a crypto mat here to show you what they look like. So you can see the 3 different ones, and these were all rendered with the tool. Next up is object visibility. I will be doing further tutorials on what the object visibility does, was including demonstration scenes and renders to show you how each of these 3 settings work. But to put it in basic terms, the exclude objects section, this will hide any object that you put in to this array. So if you don't want to render the skeleton, you can just add him to this array, and on render, it won't make any changes to the viewport, but on render, the skeleton will be invisible. The trace object section is similar, but it will hide the object, but it will keep the setting called hidden shadow on. So that way, even though your object is hidden, it still affects the indirect lighting, and it still casts a shadow on the environment around it. Holdout actors only works in versions 5.2 and up, and it only works for path tracing renders as of currently. But what it does is for any object that's put inside, it will create a holdout, which is a cutout of the scene. So wherever the skeleton is in the scene will be just a black cutout. And what this does is it allows you to create easy merges for different render layers. So if I wanted to render the skeleton on a different layer, then I could use the holdout actor to create a cutout of it in this pass, and in the other pass I would render just the skeleton so that I could do just an A over B over merge in Nuke or whatever compositing engine that you're using in order to seamlessly integrate those 2 objects together. The last section is end display. This was added specifically as a request, so anybody who uses end display and wants to be able to render light groups or cryptomats and other tech PPMs in a quick and easy way, it will give you the same options that you get in the movie render queue so that you can render those passes. So now that we have all of our options set up here, we can just go ahead and save our scene, and we'll hit render, and let the tool do its work. Okay, so now that we have it all rendered out, you'll see the different passes that we have. We have our primary, our tech pass, our 3 IDs, and all of our lights, including our emissive light. This is what we rendered out of Unreal, being viewed just through sRGB. And we've done a bit of compositing on all the passes here. And this is our final product.